Okay, so we have some basic features of reality. We have length, we have mass. So length, how stretched out something is, mass, how much stuff something has. We have space. That's just how much space something takes up, how stretched out it is in 3 dimensions. Length, mass, space, time, how long something lasts, and then we have temperature. How hot something is. So those are just some features of reality. We're thrown into the world, nothing's explained, and we experience these 5 things. And so to help organize them, we can think about them clearly and methodically by referencing a standard. And the units are standards for each of these things. And so for length, we're going to deal with the metric system, which is the unit used for science. The basic unit for length is the meter. The basic unit for mass is the gram. The basic unit for space can be considered the liter. For time, you might say it's the second. And for temperature, there are a couple, but you would want to be aware of, say, degrees Celsius and also Kelvin. Degrees Celsius, the standard for degrees Celsius is water. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius, so it's a temperature scale based on water. And then Kelvin is a temperature scale based on absolute 0, the coldest possible temperature. Even subatomic motion stops at 0 degrees, or at 0 Kelvin. Kelvin isn't in degrees, it's just Kelvin. Okay, so for 9, 10, 11, 12, they're really just asking you to give the abbreviation for these different types of units. So for 9, for example, for A, they give you a gram. And so the gram is our mass unit. And gram is a long thing to write out, so the abbreviation for it is just a lowercase g. Liter. Liter, we saw that was a unit for space. The liter. And the abbreviation for liter, if you didn't want to write that all out, it would just be an uppercase L. Degrees Celsius. Degrees Celsius. That was a temperature unit, the temperature unit that is modeled on the behavior of water. That is the little degree sign and then a capital C for Celsius. NA just means not applicable, so you don't have to pay attention to that. Second is a unit for temperature, or I'm sorry, for time. Second is a unit for time. And the abbreviation for that is just a lowercase s. So you can see that a lot of these abbreviations are pretty straightforward. Okay, so then for 10, same thing, give the abbreviation for each of the following. Here, though, they have a kilogram. Now, some of these will have a prefix. This is how the metric system is structured. So you want to separate in your mind the prefix from the fundamental units. The fundamental units are these that we talked about at the very beginning. So the fundamental unit here would be the gram, this gram. And we saw that was the abbreviation for gram was just a G. So that's that abbreviation. Now, the metric system is so clear and crystalline and beautifully logical because it takes these fundamental units right here and it just either multiplies or divides them by 10 a bunch of times to get either bigger units or smaller units. And so kilo is a prefix that means 10 times 10 times 10. In other words, 1,000. So a kilogram is 1,000 grams. And the abbreviation for kilo is just a lowercase k. Kelvin, we saw that's the temperature unit, and it's the one that's based on absolute 0. Absolute 0 is 0 Kelvin. The abbreviation for that is just a capital K. Notice it doesn't have a degree. It's not degrees Kelvin. C, not applicable. Don't worry about that one. D, meter. Now we saw that the meter was the unit for length up here. So the meter is measuring how extended something is, and the abbreviation for that is just a lowercase m. Millimeter. Now again, we're running into these prefixes. Milli is a prefix, but we can see that the meter part is length, just like before, and the abbreviation for meter is just a lowercase m. Milli is, and we said that these prefixes are all representing powers of 10. So milli is 1,000th. It's 10 to the negative 3, third power. And the abbreviation for milli is lowercase m. So millimeters, the abbreviation is lowercase m. 11, same idea as before. So it's asking about the abbreviation, but now we're running into lots of these prefixes. So here we have milli again. Grams. Grams are telling us mass. We saw how the abbreviation for gram is just a lowercase g, and then milli, which means 1,000th. So there are 1,000 milligrams in 1 gram. A milligram is 1,000th of a gram. Milli just has that abbreviation of a lowercase m, so mg is milligrams. Deciliter. Now we can recognize liter. We saw that as one of the fundamental units, and so we see that deci is a prefix. Liter, which we saw up here, was the unit of space. The metric unit for space, how much space something takes up. So we have the liter, and the abbreviation for the liter is a capital L, and deci means a tenth, and so that's a lowercase d, is the abbreviation for deci. For C, we have kilometer, and again, looking at that, we can see our base unit of a meter, so everything in front of that, which is kilo, is going to be a prefix. For meter, we saw that up here, it was the unit for length. The meter is going to be that lowercase m, and then kilo, we saw before, it's a lowercase k. So notice for a lot of these, not all of the prefixes, but for a lot of the prefixes, they're just the lowercase letters for the letter that the prefix starts with. Then D, centigrams. So centi here is going to be our prefix. We recognize grams as one of those base units, specifically the base unit for mass. So we can write gram, and we know the abbreviation for gram is just that lowercase g, and centi is 100th. The prefix for centi is lowercase c. So a centigram is 100th of a gram. There are 100 centigrams in 1 gram. And so that would be lowercase c, lowercase g. Last but not least, 12. Again with the abbreviations, same game. We see gram, and we've seen gram before. That's going to be the base unit. And then giga is going to be the prefix. So gram, we saw the abbreviation for gram, which measures mass, is just a lowercase g. Giga is going to be an uppercase g. We have megameters, and we can see the meters. Meters measures length. So here, this meter is abbreviated just with the M. And then for mega, we're going to have a capital M. So we're seeing a couple capital letters here. For giga, we saw a capital G. For mega, we have a capital M. And then microliter. This is an interesting one. We could see that we have the liter, which is a unit for space. So we have a liter here, and that's going to be our base unit. You can abbreviate liter just by getting the capital L. Micro is an interesting prefix. It's a millionth, so 10 to the negative 6th. So a millionth of a liter, that's a microliter. And the abbreviation for it is actually the Greek letter for M. Notice we couldn't have used a lowercase m because that's being used for milli. We couldn't have used an uppercase m because that's being used for mega. And so for micro, we're going to use the Greek letter for m. If we run out of English letters for m, we'll use the Greek letter for m, and that is a mu. A mu. It sort of looks like a U, but with the tail on the left side. So mu, and that's microliters, millionth of a liter. You scored a microliter out, it looks like there isn't even anything there. You could barely see it with the naked eye. But it's often used in research. And then nanosecond, we see the second. Second, of course, being a measure of time. And so we can take that second, abbreviate that just with the letter S, and nano, which is a billionth. That is the prefix for a billionth. That we can just write with a lowercase n. That's the abbreviation for nano. So for a lot of the prefixes for the metric system, they're the lowercase, but we did run into giga and mega, which are a couple important exceptions. And then just because the letter M shows up so much, watch out for the mu, the Greek letter mu, for the to represent micro. And that's just some practice associating names with their abbreviations.